Hi, so I'm just going to go through an example of standard deviation. Now, to work out standard deviation, you also need to know what the mean is first. Now, we can do this by using a calculator, or we can do this by hand. So this video is going to go through the process of doing it by hand. So let's first of all work out what the mean is, because we need the mean to be able to work out the standard deviation. So when you have got a frequency table, so you've got a value and how often it appears 4 times, another value and how many times it appears 3 times, and so forth. So a value and a frequency. So 2 appears 4 times. And we've got 4 appears 3 times. And 6 appears no times. Now, I could just choose not to write anything, okay, but I'm just going to write that in for the moment. And lastly, 8 appears twice. So you've got 4 lots of 2, 3 lots of 4, no lots of 6, and 2 lots of 8. Okay, so when we work that out, that's 36. Now, we have to appreciate, well, what is our total frequency? How many numbers do we have? Well, we have 4 numbers and 3 numbers and 2 numbers. Okay, that works out as there being 9 numbers. So I'm adding up the frequency. 4 plus 3 plus 0 plus 2. There's 9 numbers. So, what is 36 divided by 9? It is 4. So 4 is the mean value for this set of data. The numbers 2222, 444, 88. That list of numbers is written as a frequency table, and if you want to work out the mean, if you add them all up, we get 36. Divide by how many numbers there are, 9, and we get the answer 4. So we're going to use that value of 4 to work out our standard deviation. So our standard deviation, what we're wanting to do here is, now the whole idea of a standard deviation is it is a measure. It's a strange measure. It's an odd number. You can't really work out what's going on with it, but it describes in a sort of way how far away all the numbers from the mean. So there's a process. Okay, so what we're going to do is we want to know how far away are each of these numbers from the mean. So the number 2, how far is it away from 4? Number 4, how far away is it from 4? 6, how far away is 6 away from 4? And 8, how far away is 8 away from 4? So to do that, we're just going to write these out. We're going to say, okay, 2 take away 4. We're just working out the difference between each number and the mean. And we square our answers. Okay, we have 4. Take away 4. Difference between 4 and the mean. And we square our answer. Difference between 6 and 4. And square our answer. And lastly, difference between 8 and 4. And we square our answer. Okay, so now, okay, how many times did 2 actually happen? Well, it happened 4 times. So what we want to actually have here is we want to have, well, okay, well, the difference between 2 and 4 is 2. Now we have to square that. There's a bit of a process, okay? You just have to learn this. We have to square them. It's a square of the differences, okay? So, but it happens 4 times. So I want 4 lots of the square of the differences. Now, this number 4 here appeared 3 times. So the difference from the mean happens 3 times, so I want 3 lots of that. This appeared no times, okay, so I want that appearing no lots. And lastly, the 8 and the 4, the difference between 8 and 4 is 4, and I square that. How many times did it appear? Twice. So what have I got there? Okay, I've got taken each variable and found out how the difference that is from the mean. I have to square each of those differences, and I multiply each of those squares of the differences by how many times it occurred. So 4 lots of 2 take away 4 all squared, 3 lots of 4 take away 4 all squared, no lots of 6 take away 4 all squared, and 2 lots of 8 take away 4 all squared. So that's what I've been talking through there. And on the bottom, I'm going to have my frequency total. So my frequency total is 4 and 3 and 2, which again is the 9. Okay. Now, to work out the standard deviation, what we actually want is the square root of all of that. Okay, the square root of all of that. Now, I still think you should just sit there and just work out each part on the calculator first, right? Okay, so if you work that through on your calculator, okay, you're going to end up with 4 lots of 2 squared, 3 lots of nothing squared, no lots of 2 squared, and 2 lots of 4 squared. That's all being divided by 9. So, what I get is 16 plus 32 is 48. I still have the 9 on the bottom. So what's the square root of 48 divided by 9? Okay, so that's basically the square root of 5 1/3. That's what 48 over 9 is. So whatever the square root of 5 1/3 is, okay, it works out at approximately, I'll write down the bottom here, sorry, approximately 2.3, rounded to 1 decimal place. Now you can do that bit there on your calculator, okay? I mean, you can do each individual part in your calculator if you want to, but this is the process of doing it, quote, by hand. You first will work out your mean. You then have to work out the differences between each value and the mean. You square them, and you multiply each of those squares, the differences, by the frequency that it occurred. Once you've done all that for each of the values, you divide it by the total frequency, and whatever that is, you square root your answer. Okay, it's a process. You just have to practice it. There's no simple way of doing this. You just have to practice, practice, practice. Okay. However, for examination purposes, you only have to do either the calculator or doing it by hand, like we have here. You don't need to know both. Whatever you prefer to do, whatever you're happier with, you can learn both methods if you wish. Okay, but in an examination, they won't insist on just one or the other. That they'll just don't care. Just as long as you can work your way through, work out the mean, and work out the standard deviation. So I'll just, as a final, the idea of a standard deviation is it's just a way of describing how spread out the data is from the mean of the data. That's all it's there for. And it only really comes into play when you actually start comparing two sets of data. Okay, so you'll find later on in the exercise 8.6, you'll find there's a few questions which get you to compare two sets of data. So in question 13, you get to compare root 1 with root 2, and you find that root 1 has a smaller standard deviation. Therefore, we can say that root 1 aren't quite so spread out. They're a lot closer together. They're less erratic. Okay, so standard deviation, that 2.3 doesn't really mean anything much to me. But if I compare it to another standard deviation, I can start talking about how spread out something is. It really, as a statistical process, it really comes into its own with when you're looking in sort of science, medicine, lots of different scenarios where you're looking at how much data is varying by.